So let's take a look at an oversimplified Django app that we might want to test and look at a classic way of testing it with the Django test client, and then compare that to how we might do it with mock objects. So if you've ever done the Django tutorial, you might recognize this index view and the model. And this very first view here is a really simple, really overly trivial Django view. So even if you're not using Django, you can probably just about work out what's going on here. We have a view that receives a request and it returns an HTTP response. Very, very simple. So here's how we might test that using the Django test client. We inherit from the standard Django test case. This sets up a test database for us. I think it starts a transaction as well, so that we can access our code, the system under test, and then the client, it fakes out an HTTP request. So there's no real HTTP request being made, but it does go through all of the Django, all of the WSGI middleware we might have configured. It goes through the URL routing. So this is great for integration tests, where you want to test that everything is wired together correctly, and it's good to still have these high-level integration tests. The problem is, for a unit test, what we're actually trying to test is 2 lines of code. And okay, so we haven't written much test to code it. It was very easy to write this test, so it's very tempting to write your test this way. But what you're actually exercising is hundreds of lines of code. I've never counted how many lines of code, but there's potentially even thousands, because you're first of all, the Django test case is setting up and tearing down the database around the test, and you're going through all, as I said, all of the Django middleware. So in order to test that trivially simple view, we're exercising a great deal of code. If we wanted to unit test this, test that it behaves correctly, the right thing to do is to not use the test client, but to call the view directly. So this is what this second test here does. We've imported the view, we need to call it with a request, and then the asserts here are very similar. Now, this view doesn't do anything with the request object. So in actual fact, you could just pass in any arbitrary object. But this just illustrates the point that a very common way of injecting mock objects, fake objects, into the system under test is just to instantiate them and then call parts of your system under test with them. So that's the most trivial way of using mock objects. And in actual fact, for this kind of use case, Django provides a class, the request factory, which makes it very easy to create sort of fake requests that we can use for calling views directly, rather than going through the Django test client. You all with me there so far on this? So let's look at a slightly less trivial view and look at how we might test that. So this is the index view or a simplified version of the index view for the poll application from the Django tutorial. So poll here, this is the Django model. What it does is it fetches all of the polls we have in the database, and it passes the list, renders the list to a template that just produces some links showing all the polls. If we look at what the template is doing, it simply iterates over every poll in the poll list, and it puts the poll ID into the link and the poll question as the contents, the text of the link. So let's see how these poll objects are defined. That's our model. Every poll has a date, the ID we get automatically, of course, and the question, which is some text. So very, very, very simple. The problem is, if we call this directly and we don't use the Django test case, it's going to access the database. So in order to do this, we would still need a real database behind we'd need to set that up and possibly populate it with some questions to test that those are rendered correctly, and that's all going to take time. If we go back to the previous test we had of the first view, that's going to take, although it's not doing very much, it's still going to take some measurable amount of time, I think about 70 milliseconds, whereas the calling it the second test that didn't use the Django test case, we were able to use the standard unit test case there. That's going to take substantially less time. And okay, so 70 milliseconds might not sound like an awful lot, but when you have hundreds of these tests or even thousands, that's a big difference. It's the big difference between having a set of unit tests that you can run in between every change, or a set of unit tests that, well, you run once maybe before you push up to your repository. So we have to test this view that accesses the database. What we would ideally want to do would be to fake out that database access and replace the poll with some mock that behaves in a known way and doesn't require a real database to use. And I just so happen to have cooked up a test like that. And what that does is that uses the patch decorator or context manager. And the job of patch is to replace objects in your system with mock objects. Patch is highly flexible. There's a couple of variants on it, but the easiest way of using it is to specify the name of the object we want to replace under the path you would import it from. So inside the view, we were directly accessing the poll object, and it's looked up by name. So this command here says to patch, inside the views module, just highlight the right bit of it, replace the poll object, and we haven't provided an object to replace it with, so patch is going to create a mock object for us, and that's what we get here. So within the scope of the body of the with statement, the poll object inside the views model is replaced with a mock object for us. Now that's done as a context manager using the with statement. We could also do it as a decorator. So this is how we would do it as a decorator. Just uncomment that. And what if we use it as a decorator, what happens is patch passes the mock it's created into the function it's decorating as an additional argument. And in Python, monkey patching things like this is very easy. It's very easy to take the views module and stick a different object to replace the poll object. What is difficult in Python, because of the complexities of the Python object model, is unmonkey patching, is safely restoring the system state back to the way it was for the next test to run on. And the last thing you want to do is having test state changes leak through from one test to another. If we swapped out the poll object for a mock object in our test and then just left it in place for the next test, they're going to get behavior that they don't expect. Any integration tests that rely on actually using the database are then just going to be broken. And patch is very battle tested. It handles putting things in place for you and then restoring the system to how it was once the scope has been left, either the scope of the function or the scope of the with statement. Okay, so we've replaced the poll object with a mock object. If we go back and look at the view again, what we need to do is we need to configure the result of calling poll.objects.all. Now with mock objects that's very straightforward. we can create a set of fake pole objects. Each pole just has an ID and a question. So we create a list with a couple of them and just set that as the return value on our mock pole objects.all method. Now, if you notice inside the list of poles that I've created, I've used non-callable mock. That's something that's again new in mock 0.8. The reason for this is that Django template rendering, if you pass in callable objects, it will call them. It's a bit too clever for its own good there. So we can use a mock that isn't callable so that this ID and the question will be used. Now again, we're setting these attributes in the constructor here. This is again something that's new in mock 0.8. Let's just switch to the interactive interpreter so I can just show you that in action. We set these attributes in the constructor, and they're very straightforwardly they're set. This was a new feature in 0.8. If you're using mock 0.7, you have to construct the mock and set the attributes separately. Not difficult, just extra lines in your code. In this one, we're setting a specification on the mock that limits the API that's available to the mock. That's something we'll see how much time we have in this screencast and see if we get a chance to talk about limiting the APIs on mock objects. If not, there's very good documentation that you can look up. Okay, so having created our mock request as before, we can again call the view directly. This is the nice thing about using mock objects, mocking out the database access. We can use the standard unit test case, so we don't have hundreds of lines of code being executed just to call our view. We get a response back, and we can just assert that the questions that we expected to appear in our response do appear. If we wanted to do more sophisticated checking, we could use something like LXML. I've had a lot of success recently using PyQuery as the wrapper around LXML, and that lets me use jQuery style or CSS selectors to to traverse the structure of HTML and make asserts about it without having to do sort of test comparisons on HTML. Okay, any questions about that? This use of mock before we go on?
Yeah. Knowing the name to pass in to patch is a little bit tricky sometimes. Can you give us some examples of when you would use the name of where an import lands versus where it comes from?
Right. Yes, that's a very good point. Okay, so the way patch works is very closely tied to the way Python works, strangely enough. So let's go back to the views module. So the pole object is actually defined inside screencast.sumapp.models. So that's where it's defined. And I'm going to switch tabs back again. Where we're patching it is inside the views module. We're not replacing the definition. What we're actually doing is we're replacing it where it's used, and how I try and describe it is that where you patch things is where the name is looked up, because what's happening is when we execute this import from screencast.sumapp.models import pole, what we're doing is inside this views module we have a name pole, and that name is bound to the pole object that was created inside models. But the name, this name pole, because of the way we've done the import, now lives in the views model. And so when this code, when our index view is executed, the poll name is looked up inside the current namespace. And what patch is doing is it's overriding name lookup. It's saying within the scope of this context manager, or within the scope of this decorated function, when this name is looked up in this scope, this namespace where I've done the patching, you will get my mock object instead. So an alternative import might, it's very common in Python, might be, instead of importing poll directly, we might just import the models module and access the name like this. And inside this code, the poll name is not being looked up in the current namespace. The poll object, or the poll name, is being looked up is now being looked up in the models namespace. And so if we just overridden the name poll inside the views module, well, there's no poll name there to override, and by default patch will now say you're asking me to override something that doesn't exist. We'll throw an exception when it's used. There is a way, there's a create keyword argument. You say create equals true, and that says I know this name doesn't exist, but I want to create it anyway. This is the sort of if you really know what you're doing aspect of using patch. So suppose the code looks like this, and the poll name is being looked up on the models namespace. We have to change the way we do our patching, and we have to say, instead of patching it in views, this name is now being looked up in models, so we do our patching in models instead. Is that clear enough?
Yep.
And that's kind of fundamental to the way patch works. And so if you have any questions about Python testing in general, if you're interested in Python testing, there's this mailing list called Testing in Python, and I advise joining it. It's a great place to discuss testing practices. We have all sorts of interesting discussions, but it's not very high traffic. But a significant proportion of the questions about mock tend to be about this, well, my patching isn't working, or it's not behaving as I expect. So it's an important concept that you do the patching where the name is looked up, that what patch is hooking into is name lookup. There is an alternative form which works slightly different. So suppose here we go. So you can do patching on objects instead of passing in the reference by string, but we still have to say I want to. So I have the models module as an object here, but we still have to say I want to patch the poll attribute on that. So it's still under the hood, the same thing is happening. We're still overriding name lookup, but patch.object is another way of an alternative form of patching, if you like.
I think I have a question or two for you here as well, Michael.
Okay.
Can you hear me all right? Speaking up all right?
You're a little quiet, but I can just about hear you. Go ahead.
So previously I've patched using the methods on line 33 and 34 in your example, and then
yep.
I've seen now 35 and 36. Is this now the preferred method of patching in?
Neither is particularly, in terms of the way patch works, neither is preferred, neither is deprecated. Both work fine. I quite like the context manager, because even within the scope of even within the body of a single test, I can limit the scope of the patching as much as possible. And context managers are the new hotness. Context managers everywhere.
It seems a lot easier to read, isn't it, as a way of patching?
Yeah, a little less magical.
Yeah, and passing in extra arguments to the function, to the test function, was always a little bit magical.
Well, that's good. That answers that one. The only other thought I had was, is there a way you could maybe explain if you need to, for instance, use a patched object over and over again throughout multiple test instances. You're creating a mock for that with some data, and it's built up. Is there a preferred way of doing it, like a setup and tear down, and then doing a patch there instead of patching inside the actual test itself?
There's a couple of ways you can do this. So just as context managers are the new hotness, there's also class decorators, the other new hotness. So we can use, as well as using patch as a method decorator or a context manager, we can use it as a class decorator. So suppose we know that we're going to write a whole bunch of tests, and every test in this class is going to need the we're testing all of our views, and none of them we want to use the poll database. So you have to be using Python 2.6 for this to work.
Python 2.6 or Python 2.6 or newer?
Python 2.6 or newer.
Okay.
Using a class decorator is the same. Using patch as a class decorator is the same as applying that patch to every single individual test method. And in fact, that's what patch does. When you use it as a class decorator, it just iterates over all the methods or all the attributes on the class, looking for methods that begin with test, and it just decorates them all individually. So you can see here we're back to having the created mock object passed in as an additional argument to our test method. But that's quite a handy way of applying the same patch to every single method, every single test within a class. The disadvantage of this approach is that class decorators, they are applied at the point the class is created, so all of the test methods are found and then decorated. But if you might have a base class test case that you're writing with a bunch of support methods, and you want to do some patching for everything that uses this, they're not inherited because the class decorator isn't reapplied. I did see an interesting use case for patches a class decorator by in a talk at PyCon by Carl Mayer. He was well worth watching. Testing Django, I think the talk was called, or Django testing. Brilliant talk. And he was advocating this approach of don't use the Django test client for unit testing. If you're using the Django test client, it's automatically no longer a unit test, it's an integration test. And what he was doing was applying patch as a class decorator to his test cases, patching out the database cursor inside Django itself, so that as soon if any of his unit tests touched the database, they would explode loudly. So he was enforcing this no database discipline onto his unit tests, which I thought was a very good use of patch as a decorator, class decorator.
Before you get rid of
suppose
that,
we did.
Oh, go ahead.
Sorry, what were you saying there, Matthew?
Well, before you get rid of that method there, I was going to ask a question about it, for that patch.
Go ahead.
Let's say that you wanted to override two calls. You can patch it more than one time, I believe, right?
Right. So you can do this with class decorators as well, but let's look at it with method decorators because it's a little bit more common. So this is a single thing, a single name overridden. It's very easy to suppose we had more than one model that we wanted to override. We just nest the decorators. My mouse has got very jittery.
And then you'd add a second parameter to your test index.
Yeah.
And
now two things are going to be. There is a secret. The order that these arguments are going to be passed in is the same order that Python applies the decorators. So that's from bottom up. Now this is a little bit unintuitive to some people because they kind of expect this one to be done first, the poll to be done first, then other thing. Whereas the actual order is the other way around. But and that's, I guess, because people are used to reading code linearly. But if we think about it in terms of decorators wrapping a function, which is what they do, then the order things are applied is first the function is created. So here the test index is created, and then next it's wrapped with this decorator. So this one, so the bottom one is applied first, and then it's wrapped again with the outer decorator. So Python applies decorators from the bottom up because it's wrapping the function. So that's and the order that in Patch is the same order that Python applies these decorators.
Okay,
so it may seem unintuitive, but it's actually it's just the way Python works. My mouse has gone crazy.
Yeah, it's using up a lot of CPU power doing the screen sharing. Hey, let me ask you one more question about this. On the note of only testing your actual view and not testing the other Django parts of the system, I noticed you are using the render to response in your view. Would it make sense to mock that out?
I was hoping you wouldn't notice that.
Okay, so you would probably mock that out too?
Okay, well, so if we look at how this is, go back to the view, it would be perfectly reasonable to mock out render to response as well and just check that it's called with the expected arguments. However, you're not then testing all of your code. We have some logic here inside our templates that is no longer tested. I do like to test logic in my templates. I don't test particularly the fixed parts of my templates. I don't test that the header appears, and I don't test that the footer appears, although it is nice to have maybe some integration tests that important parts of your template, even if they're fixed, are there. But I do think that logic inside templates should be tested. So yeah, I kind of punted on that question in this particular test and hoped that no one would pick me up on it. It would be nice if there was a more direct way of testing logic in templates, but you can't really do that without going through the template engine.
Oh, that makes sense. So you are testing all of the code, even the template.
So, and I would have tests for logic in a separate unit test for logic in templates, yes. So if we have different branches in our template logic, I would want separate tests for those branches, so that logic is covered. So one thing that we haven't looked at is why is Magic Mock called Magic Mock, which I'm sure you're all burning to know about. So the original, okay, so one of the few places where it's okay to do from module import star is at the interactive interpreter. So the original mock class, which still exists, is just the straight mock. We also have Magic Mock, which is the more capable variant and the one you should generally use. And the reason it's called Magic Mock is because it has support for the Python so-called magic methods. I actually prefer the term protocol methods because they implement the Python protocols. So for example, Python has a numeric protocol that allows objects to behave like numbers. Magic Mock has all of these protocol methods, all the useful ones anyway, pre-implemented for you. So we can do mock to the power mock divided by mock, and that returns us another mock object, and you can see there which magic methods have been called. So the straight mock object rather than magic mock, so the instances of mock rather than magic mock don't support magic methods, and sometimes you need an object in Python code that doesn't respond to particular operations. You may want you may have code that tries to index into something as if it was a dictionary or a list, and if that fails, treat it differently. And so in order to be able to simulate both behaviors, you need an object that can respond to that and an object that can't. So that's why both exist, but in general the magic mock is the most capable. And we can look at how the this magic method support is implemented in a very similar way to the standard methods. You can see there that if we call int on a magic mock, it's pre-configured to return 1 as a result. This is because if we look at what's been called on this mock object, the dunder int, the double underscore int double underscore method has been called. This is one of the few places in Python where there's some strict type checking. If dunder int returns anything other than an integer, Python will raise a type error. So we pre-configure int there to return an object of the appropriate type. But we can make an assertion that that's been called. So we can configure we could configure int to return a different number. So the magic method support on magic mock is pretty straightforward to use. Now, if you noticed from the the constructor call here, I used the spec argument, and I mentioned earlier that spec is used for limiting the API of mock objects. One of the classic problems with using mock objects is that because they have an unlimited API, if you have unit tests that fake out part of your system under test with a mock object, so suppose you have some backend class that you're patching out with a mock, and you have unit tests that use that backend class in a particular way, and then you do some refactoring and you rename some methods or you remove some methods on the real backend. Your tests that just have mock objects, because these mock objects can be used in any way, they're going to carry on parsing even though they're now using these production classes in invalid ways. So it can be very dangerous. You can have a whole set of parsing tests but a thoroughly broken system. So what spec does is spec say create and back up a step. Let me give you a further illustration of the danger of this. So here we have a mock object that we've called, and we want to make an assertion about how it was called. Notice the typo there. Instead of calling assert called with, I called assert called with. And instead of blowing up and Python saying, but there is no assert called with, this is a mock object. It can have whatever API you want, and something that should be an assertion is no longer an assertion. And what's worse is if this assertion should fail, something that should be a failing test is now just nothing. We're just calling a method on the mock. So when we create our mocks, we can say, I want you to behave like an integer. I want you to use the int class as your specification. And if we now do a dir of the mock and look what methods are available, we can see some of the mock methods, but we can also see the attributes that would be available on a real integer. So dir is giving us telling us what's actually available on this mock. And if we now try and call our typoed method, we now get an attribute error, as we should be. The only attributes available on this mock object are either the convenience methods and attributes like mock calls and side effect, or the attributes that would be available on a real integer. So I recommend using spec wherever possible, and there's support for that in patch. So we can do. So we can patch out foo, and we can say use spec as an integer. One thing you can also do is when you're using patch is you can say spec equals true, and then patch, because it's replacing some object, it can just use the objects it's replacing automatically So inside this, the scope of this context manager, foo will have been replaced. You can see that it was replaced with a non-callable mock, because spec knew that our foo object here isn't callable, so we should have a non-callable mock to represent it, and accessing foo.bar failed. Okay, that's the basics of mock. Should be enough to get you started. There's some very interesting stuff in 0.8, like something called auto-specking, which is a more powerful variant of spec. I recommend looking at that. But do you guys have any more questions?
I think that we've covered enough for this one, but it sounds like we could go on and on. So if a person needs more information about mock, what resources do you feel are the essential?
I can always go on and on. Okay, so the best place to start for information is the PyPI homepage, the Python Packaging Index. So if you install mock with pip, this is where it comes from. And this has got links to the, if you want to report a bug or request features, to the Google Code repository, and the documentation either on my website or as a PDF. And it's also got a link to that testing in Python mailing list I mentioned. So that the address there is pypi.python.org/pypi/mock. The documentation is on my website, voidspace.org.uk/python/mock. And there's some very good documentation covering all the different patches, the helpers, and the mock classes. But there's also there's a getting started guide, but there's also a set of further examples, which are some slightly more advanced use examples of mock in slightly more either advanced or complex mocking scenarios. Various ways you may want to use it. It's worth having a browse through that and seeing if any of those mocking scenarios are stuff that you may want to do. There'll shortly be very soon there'll be a mock 1.0 alpha release, and this is going to match the version that's in the Python standard library. There've been a few additions of a couple more helpers, and one obsolete deprecated bit of code has been removed. So there'll be a mock 1.0 release any day now.
Great. Michael, thanks a lot for taking the time to explain this. We're going to share it with the world. We like to make sure that this knowledge, this really useful knowledge that we're using in various parts of Canonical, make it out to the world. So we'll make sure to publish that link so you can share it with your colleagues. Thank you for other people who participated, Hampton, David, myself, Matt Newsom. Thanks for your questions. And I guess that is it for today.
Thanks,
Thank you,
Michael.
Matt. Thanks, guys. Bye now.
Bye-bye.